Whenever we have problems that involve distance, speed and time, we'll tend to use the same equations. This equation here, distance equals speed multiplied by time, or time equals distance divided by speed, or speed equals distance divided by time. If you have problems remembering that, just try and imagine if you were traveling at 80 kilometers per hour for 3 hours. Well, how far would you go? It'd be 80 kilometers every hour for 3 hours. You would have to travel 80 times 3, 240 kilometers. So that distance, the 240, we got by multiplying the speed by the time. So the distance equals speed multiplied by time. The other two equations are just rearrangements of that equation. This equation here comes from this equation. We've just divided both sides by speed. And this equation here is just this equation, but we've divided both sides by time. In example 7, this is an example of a distance and time and speed problem. The information given is that your school is 8 kilometers away by bicycle from your home. When you cycle home from school, you go a little bit faster. You go 5 kilometers per hour more than you do when you go to school. And then the last piece of information is that the combined journey, that's to school and back, takes 54 minutes. And you're asked, how fast were you traveling to school? Okay, so you're asked, here's a table here which you're going to try to fill in with the distance, the speed and the time from home to school and from school to home. And there are pieces of this that are quite easy to fill in. For example, the distance should be 8 kilometers. The speed, well, we'll have to do some work there. And the time, again, those two things we know, however, should add up to 54. So perhaps we can do something with that. First of all, the distance from home to school and the distance from school to home, in both cases, is 8. Now, the speed that we go from home to school is the thing that we are being asked for in this problem. How fast were you traveling to school? So we'll call that x. And we're also told that we are cycling 5 kilometers per hour faster when we go home because there's a wind behind us. So if that's the case, then going from school to home should be x plus 5. That's 5 kilometers per hour faster than home to school. Now, how do we calculate, or how do we get an expression for the time it takes to go from home to school? Well, time was equal to distance divided by speed. So since that was the case, we should have 8 over x as the time to go from home to school. And likewise, to go from school to home should be 8 divided by x plus 5. The distance divided by the speed, again, should give you the time. Now look at these times. This time here is a little bit more than this time here, but the two times should add up to this 54 minutes total. So that's what gives us our equation, that these two times, when added up, give us 54. Now this 54 minutes causes a little bit of a problem because it's a different unit of time from the hour that we're dealing with in the speed. We need the same unit of time. So we're going to have to change the minutes into hours. And to change the minutes into hours, we just divide by 60. 54 minutes is equal to 54 sixtieths of an hour, so 0.9 hours. So the total time taken, which was 8 over x plus the 8 over x plus 5, right, for the going to school and coming back from school, should be equal to 0.9 of an hour. And there we have our equation. Not a particularly nice equation, but it's an equation that we can solve now. To solve it, multiply through by the LCD. The LCD in this case is x times x plus 5. If you do that, what you should then end up with is something that looks like this. You'll see that the 8 over x, when multiplied by x times x plus 5, the x's are going to cancel out. Likewise, we have the x plus 5's cancelling out when we multiply this by x times x plus 5. And we're just left, we have to remember this, that the 0.9 is also multiplied by x times x plus 5. Once we've got that, we can then simplify that a little bit. It should look like this. Notice that we've multiplied out the 0.9x times the x plus 5 to get this expression here. Over here, the 8x times x plus 5 comes from here, and the 8x just comes from here. We need a little bit more space at the bottom, so I'm going to shift this up. We've now got to solve this equation. Can you guess what kind of equation we're going to have here? It has an x squared in it. We have something that should be familiar to you now. It's a quadratic equation. 0.9x squared minus 11.5x minus 40 equals 0. Now I guess you could try to factorize that, but that's going to be very difficult. The easiest way to deal with that is usually to try to solve it using the quadratic equation. So that's your x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. In our example, we have a equals 0.9, b equals negative 11.5, and c equals negative 40. If you do that, what you should then end up with are two possible answers: 15.62 kilometers per hour or negative 2.84 kilometers per hour. Now let's just think, how much sense does it make for a speed to be negative? Well, none. So the possible value that we want is 15.62 kilometers per hour. And that's the speed at which this person went to school.